Good evening, viewer. Welcome to our Glory Globe TV. Here is a most breaking news for our viewer. In the most massive test to date, physicists have proved a major paradox in quantum mechanics and found it still holds even for clouds of hundreds of atoms. Using two entangled Bose-Einstein condensers, each consisting of 700 atoms, a team of physicists co-led by Paolo Colagici and Ivy Lee of the University of Basel in Switzerland has shown that the Einstein-Podolsky Rosen, that is called EPR paradox, scales up. The researchers say this has important implications for quantum metrology, the study of measuring things under quantum theory. Our results represent the first observation of the EPR paradox with spatially separated massive many particle systems, the researchers write in their paper. They show that the conflict between quantum mechanics and local realism does not disappear as the system size increases to more than 1,000 massive particles. Although we are pretty good at mathematically describing the universe, our understanding of how things work is patchy at best. One of the tools we use to close one of the gaps is quantum mechanics, a theory that arose in the early 20th century, championed by physicist Niels Bohr for describing how atomic and subatomic matter behaves. In this tiny reclaim, classical physics breaks down when the old rules no longer apply, new rules must be made. But quantum mechanics is not without its flaws, and in 1935, three famous physicists found a significant hole. Albert Einstein, Boris Podolsky and Nathan Rosen described the famous Einstein-Podolsky-Rosen paradox. Nothing can travel faster than light, right? But it gets a bit tricky with quantum entanglement. What Einstein referred to as spooky action at a distance. This is where you correlate two or more particles so that their properties are linked. If one particle, for example, spins one way, the other spins to other way. These particles retain this link even over large distances, and it's unclear how or why. Scientists do know that if you measure the properties of one particle, you can infer the properties of the other, even over the distance. However, under quantum mechanics, the particle won't have those properties until you measure it, a quirk explored by the Schrodinger's cat thought experiment. And under quantum mechanics, if you know one property of a particle such as its position, you cannot know another, such as its momentum with any certainty. Yes, this is the Heisenberg uncertainty principle. The classical physics concept of local realism also states that for an object or energy to affect another, the two have to interact. The EPR paradox, therefore, is complex. When you measure one particle in an entangled system, the measurement somehow influences the other particle, even though the measurement is not taking place locally. You also know more about the particles than is allowed under the Heisenberg uncertainty principle, and somehow that influence happens instantly, denying and defying the speed of light. The EPR paradox therefore suggests the quantum mechanical theory is incomplete. It does not fully describe the reality of the universe we live in. Physicists have mostly tested it on small entangled systems consisting of just a pair of atoms or photons, often in what is known as a Bell test, that is called after its devisor physicist John Stuart Bell. So far, every Bell test conducted has found that the real world behaves in a way inconsistent with local realism. But just how deep does the paradox go? Well, is where we get to the Bose-Einstein condensates, a state of matter created by cooling a cloud of bosons to just a fraction above absolute zero. At such low temperature, the atoms sink to their lowest possible energy state without stopping completely. When they reach these low energies, the particles' quantum properties can no longer interfere with each other. They move close enough to each other to sort or overlap, resulting in a high density cloud of atoms that behaves like one superatom or matter wave. Beyond the report, Glory Globe TV, Delhi, India.